Hi everyone, in this video I'm going to show you how to set up a self-hosted private Kubernetes cluster on EC2 with Kubeadm using Ansible. Alright, so if you are somebody who is interested in becoming Kubernetes certified, meaning that you want to become CKAD, CKA or CKS, then this video is for you. Alright, so you have to actually know how to set up a Kubernetes cluster like this, because the certification exam itself is taking on a live Kubernetes cluster as of today. So you should be able to know how to upgrade your Kubernetes version, do troubleshooting, create resources within your Kubernetes, and understand how the component work. Okay. Now, if you are a developer working on an application or developing an application that your intention is to containerize it and test it on top of a Kubernetes environment, you actually have to use this kind of setup to do your tests, because this is a kind of a lightweight Kubernetes environment. You don't need to incur a lot of charges to kind of have this setup, for your application. And of course, you can turn off this Kubernetes cluster when you are not using it and turn it on only when you are using it, because this is one of the key benefits of having this kind of setup. All right. So I have this architecture diagram here, and we'll be doing this in AWS. We'll be using US East 1 region, and I already have a custom VPC setup with 3 subnets. All right, we have one public subnet and 2 private subnet. In this private subnet, we will host our Kubernetes cluster. Our Kubernetes cluster is going to have 4 nodes, 1 master node and 2 worker node. Our master node will be placed in one private subnet, while our worker node will run in a separate subnet. In a public subnet, we will deploy a bastion host, and from our bastion host, we will do our cluster configuration, and of course, we'll be able to access our cluster only when we are on this bastion host. You will not be able to access your cluster or query your cluster API endpoints from your local. You will only do that when you are on the bastion host. All right. So guys, let's head over to our AWS account and start our demo. All right, guys, I'm already logged into my AWS account, and here is my AWS Management Console home screen. All right. Now I will head over to EC2 dashboard, and just make sure you are in your preferred region, and I have we are doing this in US East 1. All right, so go to instances, and you should launch instance. Okay, launch instance, hit on this and use and type your server name. I'll call this bastion host. Bastion host. Okay, and before we do this, let me pull back my architecture diagram and show you what we are doing. So the first thing first we need to do is to create our bastion host in the public subnet. All right, then later on we will create our master node in one of the private subnet called control plane, and or our worker node in another subnet called data plane. So if you have not already watched my other video on how to set up a custom VPC, you can go ahead and watch that video, then come back to this one. All right. So let's create our bastion host in the public subnet called bastion host. Okay. Now I will call my bastion host name, my bastion host server bastion host. I'll hit on Ubuntu for AMI, and under instance type I will pick a T3 medium or extra large. Let me use T3 extra large. T3 extra large. In fact, let me use T3 large. Okay, that will be enough. So I'll hit on this. Then I will create a key pair called, let me call this cluster-key. I'll hit create key pair. So under network settings, do edit and click on this drop down button and select your custom VPC. And I will select my subnet called public subnet, because I want to use this subnet, right, the public one, to create my bastion host, because from here I will be configuring my cluster. Okay, so make sure you have auto assign public IP address enabled, otherwise you will not be able to access your cluster. Okay, now I'm going to create a subnet, a security group called bastion host. I'll leave the description by default, and then under source type I'll pick my public IP. Just choose my IP and hit create launch instance. So the thing is, you need to first of all look through all your EC2 profile to make sure you have selected the right AMI and so on and so forth. So I'll hit on launch instance to launch my bastion host. All right. Once my bastion host is getting created, the next thing I need to do is to create my control plane. Remember, control plane needs to be in a separate subnet. Okay. So let's go here and do launch instances, and I will type this one master. I'll call it master-node, and I'll pick my Ubuntu as AMI. I will use T3 large as well for instant type. T3.large. Okay. And I'll use the key pair I just created for my bastion host called cluster key. Then under network settings, choose your custom VPC and control plane subnet. Okay, I'm going to use that control plane subnet right here for my control plane or master node. Then make sure you auto assign public IP address is disabled. The reason why we want to make our cluster completely private, that way we can only access our cluster when we are on bastion host. All right. So I will call this security group control plane, control-plane -sg. I'll leave the description by default, and on this one I will select custom, and then I'll go back to my architecture diagram and make sure SSH connection is only limited to my network CIDR, okay, which is my VPC CIDR, the 172.31.0.0/20. Okay, so I'll go to source and I'll type 171.31.0.0/20. Okay, I will select that and do launch instance. So that should create my control plane, and the next thing I need to do is to create my worker node. So I'll go back to my EC2 dashboard and I'll do launch instances. So here I'm not going to give any name here. Okay, so what I need to do here is to come to number of instances under summary, and I'm going to put 3 because we are creating a 4-node Kubernetes cluster, 1 master node and 3 worker node. Okay, so I'll put a 3 here, but I'm not going to give a name here. But I'll go here and select Ubuntu as my instance and my AMI, and under instance type I'm still going to use T3 large, T3.large. All right. So I will use the same key pair, and will go select use my custom VPC, and I'll be choosing my data plane subnet. Okay, I'll use my data plane subnet, and I'll create a security group called data plane dash sg. Okay, I'll leave the description by default. I'll select custom, and I'll also limit the IP source to my network decider. Okay, what is this? 172, right? .31.0.0/20. All right. So, oh, I have a typo. So let me take this off. That should be 172.31.0.0/20. Okay, I'll select this and I'll hit on launch instance. Now let me go back to my instances, refresh, and you should see these 3 instances pending. Okay, so I have to rename this instance. I'll call this node 01. You can call it worker node or whatever you want. And I'll call this node 02. Click on the check mark, and I'll call this node -03. All right. So here we have created our bastion host, the master node, and the 3 worker nodes, okay, just as shown on this diagram. All right. So now we need to now go to our bastion host and SSH to our bastion host, okay, and do some kind of configuration. Now before we do that, let's click on our bastion host, and you'll see that we have a public IP address assigned to our bastion host, and it is with this public IP address that we'll be accessing our EC2 instance publicly. Okay, and then for the master node, you shouldn't see any public IP address. That should be the same for our worker node 1, node 2, and node 3. Okay, you shouldn't see that. All right. Now let's connect to our bastion host and do start with some configurations. All right. So before we do that, let me pull up my terminal, and we will copy our key pair to a self location and then connect to our bastion host. So when I created my key pair, it was downloaded to my download folder. So I'm going to copy it over to my SSH location. So I'll do cp download and then cluster key, and then I'll copy it to .ssh location. Okay. So if I do cd.ssh and I do ls, I should see my key pair. My key pair is cluster key pair. Okay. So let me push this a little bit like this. That way we can see all the name. So so if I do ls-la, you can see that my key pair has read-write permission, but I want my key pair to only have read permissions. Okay, so I'll do chmod 400, and I'll pass my key pair name, and I'll hit enter. Now let's connect to my EC2 instance and then do some sort of configuration. So I'm going to go back to my dashboard, and I'll select my bastion host and do connect and copy this SSH string, go back to your terminal, paste, and hit enter. All right, do yes. So we should land in our EC2 instance. So let's do SSH, let's do a sudo apt update /y to update our instance. All right, so that has updated our EC2 instance, and the next thing we need to do is to I want to change the host name here to Bastion host. That way we can easily identify each of our servers. Okay, so I'll do sudo hostname cdr or control set hostname to be Bastion. So if I do exit and I call back my command, you should see that Bastion here. Now, next thing we need to do is to copy our key pair we created over to this Bastion host, then test the connection from our Bastion host to the subnet, to one of the worker node or the master node. So I will copy my key pair to my Bastion host, then test XSS connection to one of these nodes in the private subnet, right? So let's do that. So before I do that, let me exit out of here, and I'll cut the content of my cluster key pair. So you remember, you don't have to do this if you are doing this in a production environment or in your private environment. You don't have to display your key pair in public like this. Okay. At the end of this video, I'm going to delete this key pair. Okay. So let me go back to my cluster, and not cluster, sorry, to my Bastion host, and I'll navigate to SSH location. I'll create a file called cluster key, same name as our key pair locally. Now I'll paste this in here and save it. So I'm going to change the permission again, shmod 400, and then cluster. Now let's test connection. So my key pair is in a Bastion host. So I want to test connection to my control plane cluster. Okay, let's test that connection. So I'll go back to my instances. I will select my master node and then copy the SSH connection string, then go back here, paste, and let's see if we'll be able to jump into our master node. All right, so we are able to connect to our master node, and let's get out of this place and see if we can connect to one of our worker node in the private subnet. So let's try that, and I'll go back here, and I will pick this guy, just copy this IP address, go back to your terminal. Remember, we are in our Bastion host right now, and then I'll paste this guy, hit enter, do a yes. Now you should see that we are able to connect to our EC2 instance in their private subnet, one of our worker node, right? All right, guys, so you can see here that we have been able to do SSH connection from our Bastion host to our control plane node and all the nodes in the private subnet. Now we need to go back to our EC2 instance or our cluster and create and do some adjustment in their firewall, and I'm going to show you how that setup is done. Now let's go to Kubernetes documentation. I'll do Kubernetes port and protocols. Right, let me do Kubernetes port and protocols, and I'll go to this documentation. So what we need to do is that on our control plane security group, we are going to be creating these firewall rules. That way, our cluster component or the cluster component can be able to talk to each other, or we have proper connection set up. Then on our worker node security group, we will set all of these firewall rules. All right. So let me move this to a separate window and security group with these configurations, right? Now, I have this set up like this. So let's start with our control plane, and let's go and click on the control plane and go to security. All right, select your security group and do edit inbound rules. Let's make sure we are on our control plane security group. Okay, now do add rules and copy this port number, go to port range, paste, and this is going to be a TCP. Okay, so it is a custom TCP. So our source says here all. So we are going to be putting our network CIDR, this one. Okay, we'll be putting our network IP address here, which is the VPC CIDR. Okay, so let's put here 172.31.0.0/20. Okay, so select this and let's do add another rule again. So copy this port range, copy this, paste here. Okay, this should still be a TCP and it says Kube API server, so we will still use our network CIDR. Select that and do add rule again. Let's add another firewall rule. We'll pick this guy. Okay, we'll paste under port range. It says serve. Okay, so we are going to go select our control plane security group, the control plane security group. All right, we will add another rule again. Paste this, and it also says serve. So let's pick our control plane subnet again. Sorry, not subnet, security group. Let's do add rule again. We will copy this, paste that under port range, and it says serve. So we'll go ahead and use the control plane security group again and do save rules. Right, that should complete our firewall rule setup for the control plane security group. Now let's go back to EC2 and hit on running instances. So select one of your worker node, go to security, check on the security group and do edit inbound rules. And then under here, let's start with this guy. Okay, do add rule, let's paste this. Okay, this one says serve and control plane. So what we need to do here under custom TCP, go get serve, meaning that you need to select your data plane security group and you have to add another rule. Okay, add another rule and let it be custom TCP, and then it says control plane. Let's pick control plane security group. Let's pick control plane security group. All right, and let's do add rule again. We are going to copy this. We will place this here. So this one says serve load balancer. So there is no load balancer security group. So we need to pick the data plane security group that we created earlier. Then let's do add rule again. So let's copy this port range and we will place them here. And then it says all what we need to hit here is our VPC CIDR 20. All right, and we need to add another inbound rule again. Okay, and this one is a custom UDP. So we are going to select a custom UDP here. Let me say custom UDP, and we will paste this here, and it also says or. So let's go use 172.0 sorry plus 31.0.0/20. Select this and hit save rules. Alright, now this complete this firewall rule addition to our worker node security group. Alright, so let's close this and hop over back to our EC2 dashboard. Alright guys, so let's head over back to our terminal, connect back to our Bastion host, and then we are going to clone the Git repository that has our Ansible script, alright, that we'll be using to bootstrap our cluster. So I have a Git repository here, and I'll say person learn, hit enter. So go to code, copy this, and don't worry about this link because I'm going to be putting the link to this Git repository in the video description below. Okay, so I'll go back here and do a git clone, paste this, hit enter, do ls cd person learn. So guys, the Ansible script is in this directory, and I'll be using Visual Studio to do the to edit the Ansible script. All right, so let me open my Visual Studio here, and I'll go to my Remote Explorer. I'll go to this SSH settings, then I'll copy the key, or the IP address of my Bastion host over here, so I can copy it from here. Let me copy this and then go back to my VS Code, and I will paste that here, save it. I should test connection and see that if that will establish connection. Okay. All right, I'm connected to my Bastion host, and I'll open a terminal here, do ls. I should see my person learn directory here, so I'll do person learn. Open that in a different window. I'm going to close that guy, and then that should open the entire directory or the Git repository for me. So once you are in here, go to AWS private K8 with Ansible. You will go to inventory, open this host.ini file, and count 1, 2, 3, 4. So I'm going to be removing the rest of this. 1, 2, 3, 4. I'll take off this. All right. So let's go copy the IP addresses of our cluster nodes and come and adjust them in here. So let me go here. Let me go back to my AWS EC2 dashboard, and I'll hop over to my master node. I'll copy the IP address of my master node. I'll go back to my Visual Studio, select all of this and do Control F. Then replace that with your master node. Okay, replace that with your master node private IP. Right, go back to your EC2 dashboard, copy the IP address of your first node, first worker node, select this, do Control F, paste that, replace it. All right, go back to your EC2 dashboard, do the same thing for the second node, copy these, go back here, select this, do Control F, paste this here, save it. Right, same thing for the last node. Copy the private IP, copy that, go back to your Visual Studio and select that, do a Control F, and then paste this here and save that. All right, so we can do a visual check to see if this actually matches what we have here. So let's make sure we have everything correctly. Okay, so let's click on the master node, cross-check this. This is the first IP here, 2.77, and let's go to the second node. First node, sorry, is 5.47. Let's go to the second node. Second node is wrong. Okay, second node is wrong. We have to, no, bottom, no, not second node, sorry. Second node is 173.4173. All right, let's go to the third node. And of course is 8589, right? So this is the wrong one. We need to take that off. All right, so let me minimize my Visual Studio. My Visual Studio code here. Let me open it a little bit, and I'm going to save this. All right, guys. So another thing we need to do here is to edit our Ansible.cfg file. So, okay, so this key pair name here is pass and learn. So we need to change this key pair name to reflect the key pair that we created earlier. That way we'll be able to, Ansible will be able to communicate to our servers. Okay, so let me go ahead and pull the key pair name here. So I'll say list.ssh. So I'll copy this key pair name here. Okay, copy the key pair name, come here and replace it. Remember, we are in our Bastion host. We are still in our Bastion host. We have cloned the Ansible script to our Bastion host. And from our Bastion host, we will be using Ansible to actually bootstrap our Kubernetes cluster. Right? So let's save this and run a test. All right, let's save that and run a test. So let me go back to the Ansible location, the Ansible script on GitHub. I'll open this, do on-prem, and I will do exi. And in here, I should see this command that I need to run to actually know if my hosts are communicable or not. So copy this, go back to your VS Code terminal. Make sure you are in the AWS directory. So I'll do cd AWS. It needs to be in a K8 first, cd K8 AWS. Okay, so run this, and let's see if, all right, now we do not have Ansible installed. So what you can do is copy this and then paste to install Ansible. All right, type AI to install Ansible. So while that is getting installed, guys, what is Ansible? Ansible is actually a push-based configuration management tool that you can use it to configure your servers at the same time. Let's say you have 1 to 500 servers, and you actually want to update patches in those servers. It is a little bit difficult to start updating those servers, maybe with a share script individually. All right, you can't do one after the other for 500 servers. Okay, so with Ansible, you can easily update or upgrade patches, even install software, remove deprecated software from the servers with Ansible at the same time, all right? So that is what Ansible is. So if you want to know more about Ansible, you can go to Ansible documentation and read a little bit about Ansible, okay? You can go to Ansible documentation and read a little bit about Ansible, okay? Because Ansible is here. All right, so go ahead and look for some of these things that Ansible does. That way you can be familiar with Ansible. So guys, let's head over back to our VS Code terminal. Our Ansible should be installed. So let's test that connection and see if it is reachable, if all our servers in the private subnet are reachable. So you can see that a ping connection is success, 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 right? There is one thing I want to show you guys here. Even though a ping is successful, but guess what? Our node in the private subnet cannot pull any data from the internet. All right, so let me show you how that works. So to do that test, what I need to do here is to copy the IP address of one of my servers, and I'll do ssh -i .ssh and then cluster. Then I'll put the IP address of my server, hit enter. So I should be in one of my server here. So let me try to update sudo apt update. So let me try to update this server. You can see, guys, that this is having difficulty connecting to the internet. All right, so what that means is that even though we can remotely do SSH connection to our server, but we cannot pull anything, or these servers in the private subnet are not reachable to the internet. Okay, so what we need to do to solve this problem is to create what is called a NAT gateway in the public subnet, and then create a route in our private route table. That way our EC2 instance can be able to pull data from the internet. So does it actually mean that our EC2 instance in the private subnet are now be able to be accessed from the local? No, that doesn't mean creating a NAT gateway makes them open to the public. No, it just means that they can pull data from the internet. All right, so let me go back to my EC2 dashboard, and we'll let me duplicate this. And we'll be hitting on VPC. Let me show you how to create a NAT gateway. So type VPC, go hit on VPC, and on your VPC dashboard, on your left hand side, go hit on NAT gateways. So let's create a NAT gateway, because without a NAT gateway, like I said earlier, we are not going to be able to pull anything. So our cluster installation is going to fail. All right, so let's create a NAT gateway here. We'll call it PubNAT, call it public NAT. Okay, now let's choose a subnet. Even though we are creating a NAT gateway that will help us, pull data from the internet, this NAT is going to sit in the public subnet, right? So we'll be choosing our public subnet we created earlier called public subnet. So let's choose that one. And with a NAT, you will need what is called an elastic IP address. So we don't have elastic IP address, so we'll be allocating an elastic IP address to our NAT. That way, that IP address will always be constant to communicate to the internet. So let me allocate one. You can see that it has assigned an elastic IP address to this NAT, and I'll hit on create NAT gateway. Please make sure this is attached to your public subnet. All right, hit on create subnet, NAT gateway. Now, since once this is getting created, let's head back to the NAT gateway, and you can see that our NAT is pending. All right. Now, let's go back to our route tables, and on your private route table, hit on the route table ID and go do edit route and do add route, and let's choose our destination to be the internet. 0.0.0/0 means internet. This is open to the public, okay? So click that and go select your NAT gateway you created. So you should see the ID here, pop NAT, okay? And then do save, right? So let's go back to our NAT and refresh to see if our NAT is available. So we have to wait till our NAT is available, okay? All right, guys, so our NAT is available now, and you can see that it has created this public IP address. In other words, the elastic IP address, and assign it to our NAT, right? So if I head over back to my Visual Studio, you can see that this update was not successful because my EC2 instance was not able to pull all the binary that they needed to update this instance, okay? So that's why you are seeing some of this warning and so on and so forth. So if I call back that command and try to update the server, you can see that the update now is getting successful, all right? Now, let me exit from this, and let's sort of start bootstrapping our cluster. So make sure that your host.ini file is properly configured. Okay, so we did a ping earlier, and our ping was successful. Right now, make sure you are in this directory called AWS-private-K8 with Ansible. That way you should be able to, run your Ansible script, okay? Because if you are not in this directory, you are going to encounter some issue. All right, so let's type Ansible playbook. So we are going to pass an I to represent our inventory location, because the host.ini file is our inventory file. So let's put inventories and put that ini file, host.ini file, and then the playbook that we are going to use is in this directory called playbook, and the name of the playbook is cluster install. So I'm going to put some details of what this playbook is actually doing. That way you should understand it. Okay, and one thing that you can do here is to go to on-prem. In the on-prem, you are going to see a manual install, and this kubeadm.install.sh should give you all the details, everything what is happening here. So it's the same thing that has been translated into Ansible script in this cluster-install.playbook.yaml file. It's the same thing, all right? So I'm going to call that cluster install here, and I'll hit enter. So this should begin my cluster installation, and I'll pause this video till the installation is done, then I'll be right back, okay? All right, guys, so you can see that the installation is done. So let me just take you a little bit on what has happened to our server. So you can see here that Ansible has gathered some facts, and meaning that they're able to reach our servers is okay. They went in there and set the host name, and so our master node is going to have a host name called master. Our worker node will have host name, node 1, node 2, and so on and so forth. So they've gathered all those facts. That means after each stage, Ansible needs to make sure that all these hosts are reachable. Okay, anything you see that is green is sort of a new thing that has happened in the cluster the one that is in yellow has just been modified. Okay, you can see that a lot of things have happened in the cluster or in the server and so on and so forth. All right, so at the end of the day, Ansible gives us what is known as a recap, meaning that they want to tell you how many things were changed in the cluster, which node was unavailable, what failed, which one was kept, what was rescued, and which node was ignored. All right, so this gives you the final statement of what has been done in the cluster. So guys, I can tell you that our cluster has been deployed successfully, and what we need to do is to navigate back to our Bastion host and test and see if our cluster is running. So we can navigate back to our control plane and test to see if our cluster is actually 100% running. As of now, we will not be able to query our Kubeadm endpoint from the Bastion host because our kubeconfig file is currently in the control plane. So we need to copy that back to the Bastion host before we can query the API endpoints from the Bastion host. So let me show you how that is done. So we need to SSH to our control plane and see what our cluster status is. So let's go back to our ini config file. ini config file, copy the IP address of the master node. Okay, let's copy the IP address of the master node, and we will do this. You can be in the root directory, and let's do SSH. So this is super simple here. Okay, so if you go back to your EC2 instance, make sure you are on your master node, do connect, then copy this SSH string, go to your VS Code, make sure you are in this directory where your key pair is saved, paste this, and hit enter. All right, now you should see that your master node host name has changed to master. All right, now let's run kubectl 8 pod and see. So we can't see any pod, and we are receiving a response. All right, let's do kubectl get node. You can see that we have a 4 cluster node with 1 master node and 2 worker node, just the way we configured, and this has been bootstrapped like 4 minutes ago. So if I do get node -o this will actually show you all your cluster configuration or some of the operating system versions and so on and so forth. So you can see that our cluster is version 1.32.8. We can see that they have only internal IP addresses, and all these IP addresses pertains to all these IP addresses in the ini file, and there is no external IP. We are using Ubuntu, the Ubuntu AMI that we used earlier, and this is just the Kubernetes version, the kernel version, and the container D, which is a container runtime for this Kubernetes. All right, so this is how you actually set up a Kubernetes cluster, all right, with Kubeadm using Ansible. So if I do kubectl get pod -a, all right, that means in all the namespaces you should see that my Kubeadm server is up and running. So this is a Kubeadm server is up and running. Now I can only access this cluster for now only when I am in my Bastion host, right? Sorry, I am in my control plane, but I want to copy my Kubeadm server config file back to my Bastion host. That way, each time I log into my Bastion host, I should just be able to query my Kubernetes endpoint from here, right? So I need to copy that. So I will say pad kubeconfig, and I'll copy this. Do not share this file with anybody, okay? But absolutely, this is a private cluster, and nobody apart from you is going to access this cluster. Now, I need to hop back to my Bastion host, and this is my Bastion host here, okay? So I'll come here and create a folder called .kubeconfig, .kube, and in here I will create a file called config. So I will say touch, or let me say vi .kube and then config, just the way it is in my control plane, and I will save this. Now let's do kubectl hit node. Now kubectl is not installed here, so what I need to do is to install kubectl first. All right, so let me do --classic. Let me do --classic here, and that should install my kubectl. Okay, so I'm trying to bring over my kubeconfig file to my Bastion host. That way I can query my Kubernetes endpoint from my Bastion, right? Now that kubectl is installed, so let me do kubectl get node again. So let's see, you can see that I'm in my Bastion host, and I can see my I can access my Kubernetes environment. All right. Okay. So I want to show you that with this kind of setup, you will not be able to access your Kubernetes cluster from your local. Okay. So let's do that. So let me go to my local, and what I need to do here is to open my Ubuntu. In fact, let me do this from my WSR, okay, which is Windows Subsystem for Linux. So let me go here and I'll open this Ubuntu. So what I need to do is to even clear anything that is in my kubeconfig file. I'll do echo.kubeconfig, and I'll do config, okay. So if I do card.kubeconfig, you should see there is no data in there, right? So I'll do vi.kubeconfig, okay. So let me paste this. I want to paste the same data over here. So to do that, let me go back here, and what am I copying? So I'll copy, I'm in my Bastion host right now. Command there, kubeconfig. So let me copy this over to my local. Okay, I should not be able to access my cluster from my local. All right, so let me save this, and I'll do kubectl get node. Okay, so I should not be able to access my Kubernetes from my local. So that is what this setup is. So you should not be able to access it from your local. You should only be able to access it when you are in your Bastion host. Right? That is why it is a private Kubernetes cluster. Now let's head over back to our Bastion host and see if we can create a pod. Okay? So let me head over back to my Bastion host and see if I can create a pod. All right, so to create a pod, run kubectl, okay, run, let me call it my pod image, have the image name to be Nginx. Okay, let's go Nginx. That pod has been created. So let's do kubectl get pod. right? You can see that your pod is running, right? Guys, this is how you set up a self-hosted private cluster. Right? This cluster is completely private and it is very, very functional. Okay. Now, one thing I stated earlier is that you can actually turn off this Kubernetes cluster and then come back, turn it on, continue with your practice, right? And I'm going to show you how to turn this cluster off and turn it back on, right? Now, let me go back to the AWS EC2 dashboard, okay? So head over back to your instances, and what you can do here is that if let's say you are doing your practice, all you need to do is to come and select on all of these things and then do this, stop your instances, okay? Just stop the instances. Remember, when you stop your instances and bring it back up, especially for Bastion hosts, the only thing that is going to change is the public IP address. But for the private IP address, everything is always going to remain the same. Okay, so then for the NAT gateway, you need to actually delete this NAT gateway. Don't worry about you are not going to be able to communicate with your cluster again. The only thing this NAT does is that when you deploy something, for example, a pod that needs to pull images from the public container registry, you will need internet. Okay, so you can always delete this NAT. You can always delete this NAT, all right? You can always delete the NAT. You can always delete this NAT, and then make sure that before you go, you should release your public IP address or this elastic IP address. So if you click over on elastic IP addresses, you should see that this elastic IP address is here. So you should come here, click on this drop down button and do release. But as of now, this is not going to be released because the internet gateway has not been completely removed. Okay, you need to remove that. Let's say you release this. Okay, you release this and you turn off your cluster, and in the next working session you need to work again. What you need to do is to create a new NAT, create a new NAT, go back to your route table and click on this route table ID, do edit route, and then add the route from, in fact, don't add any route, but just go to this NAT gateway, select the NAT gateway, and then choose the new NAT gateway you created, and then do save changes, okay? So that should take you back to your normal configuration. So that's how easy you can do this to sort of get a fully functional Kubernetes cluster that you can do for your practice. You can test something on it and make this cluster a very practice environment for your whatever you are using it for. Okay, guys, thank you so much for this video. Please don't forget to subscribe to this YouTube channel, like the video, ask your question on the comment section, and I'll be more than happy to answer that for you. Bye-bye.